Hello and welcome back to Izzo Math. Today we're going to be talking about the unit circle and more specifically radians and angles and slices within that. Angles are measured in radians just like we do with degrees. We always start from the positive x-axis or the positive horizontal axis. And to measure positive angles we go in the counterclockwise direction. So if I want to measure this angle that I create right here between my two green lines, I want to know the positive angle that corresponds to that angle. While going around the first quadrant, I know that that's equivalent to a half pi. That's what we found on our previous example. Or I can also look at if I go halfway around the circle, that's equivalent to pi. So each one of these quadrants, or each one of these 90-degree angles in the previous section, is equivalent to half pi. So if I go half pi plus another half pi plus another half pi, that ends up being 3/2 pi. So the positive corresponding angle to this is 3/2 pi. Now I can also measure this using a negative angle. Using the negative angle, I still start at the same starting point. I always start from the positive x-axis or the positive horizontal axis, but the negative, I'm going to go in the clockwise direction. And that right there has a measure of -half pi. So the corresponding angles here, 3/2 pi is equivalent to a -half pi. Just like we did with using degrees, positive is in the counterclockwise direction, while negative angles are in the clockwise direction. And the only thing that's changed here is now my measurement units are radians. Now let's take a look at the next example. We have seen that this angle here, measured as a positive angle, is equivalent to 3/2 pi. But I can also identify this angle if I go one entire revolution around the circle, which is equivalent to 2 pi, and continue back around and stop right there, and it ends up being a coterminal angle. In this case, I've traveled the distance of 3/2 pi plus an additional 2 pi, which after combining like fractions, I end up with 7 pi over 2. So 7 pi over 2 is equivalent to 3 pi over 2. And I can continue this process if I go around the entire circle twice and then end at my terminal side. I now have traveled 11 pi over 2. So these angles are all equivalent. Remember, every time I go around the circle, I have traveled a distance, an angle in radians measure of 2 pi. So any multiple of 2 pi, I can continue on and I can still pick up the same angle. The same concept lies true with negative values. If I have, here is my value of a -half pi, so I have -half pi. But if I continue on and not go there, but go make one full revolution around the circle and come back around, I have now traveled the distance of -half pi plus an additional -2 pi because I've traveled in the negative direction, and that ends up giving me a corresponding angle of -5/2 pi. And if I continue around 2 times and then pick up the circle, once again, that is equivalent to -9 pi, or an additional 2 pi. All you have to do is keep on adding 2 pi. If you keep on adding 2 pi, that just determines how many times you go around the circle. So positive and negative corresponding angles on the unit circle in terms of radians are equivalent whenever you have multiples of 2 pi. And that formula looks like this. What we have here is essentially theta plus 2 pi n radians for every integer n, which means simply a radius on the unit circle corresponding to an angle of theta radians also corresponds to an angle that can be specified here, which is theta plus 2 pi n. N represents just how many times I'm going around the unit circle. Now let's take a look at how we find out areas of a slice. To find out the area of a slice, I need to, essentially what I'm asking for is, what is the area that this given slice created? Of course, I'm on the unit circle here again in radians. I want to find out the area of that slice. We need to first remember that the area of the entire circle, or the area of any circle, is essentially pi r squared. In this case, since I'm dealing with the unit circle, obviously my r is going to be 1, but right now area of any circle is pi r squared. What I need to do then is I will need to find out what proportion that this area of this slice is of the entire circle. So This obviously is going to have an angle of theta, so I need to find out what proportion of this theta angle in the radians occupies the entire circle. And the way we set that up is basically the entire length around the circle or area is going to be 2 pi in radian form. So we want to find out what that theta is of 2 pi. This is nothing more than a proportion. That is my area of the slice, and that is 2 pi, the entire circle. And what I do now is I take that area of that slice, or that proportion of that slice, and multiply it by pi r squared. And when I do that, as you can see, I can combine my terms. My pi ends up canceling out, so I'm left with theta r squared divided by 2 will help me find out the area of any slice in radian mode of the area of any slice in radians. If a 14-inch pizza is cut into 6 slices of equal size, what is the area of one slice? So here I have my 14-inch pizza. Remember, 14 inches refers to my diameter of the pizza. So I got 14 inches. So that makes my radius from half is basically going to be half of that. So my radius is 7 inches from one side to the other side. So if I have a 7-inch radius, then I need to find out basically pi r squared is going to be pi, in this case, 7, which is my radius squared, or 49 pi. So the area of the entire pizza, is 49 pi. And it says 6 equally sliced pizzas. Well, that's essentially 1/6 of the entire pizza. So all I have to do is do 1/6 times 49 pi. 49 pi, which obviously comes out to being 49 pi over 6, and that is the area of a slice. So what I did with this is I found out the area of the entire pizza, and I multiply it by the area of the slice, or that it occupies, or the sector that it occupied. I hope this has helped, and remember to check back to ISOmath with all your math needs, and we'll see you soon.